Welcome back. Another lovely afternoon tea. That was delicious. Do you know what? I used to think I was a bit special because I had received not one but two Apple student scholarships to go to WWDC. I thought that was pretty cool until I just discovered that our next guest has received four student scholarships to attend WWDC. So now I feel half as special, but that's okay. So James Dale here, our next speaker, is an entrepreneur and developer specializing in iOS development. He's currently leading an app development studio called Friday Technologies. I hope we're going to hear why it's called Friday Technology. That's an interesting name. Previously, he co-founded US-based startup Hags, backed by Google and Box Group, now acquired by Snapchat. James is a serial app developer, creating apps such as Clean Sky and Ruler, I see, yeah. He previously worked at Apple in the ISE Special Projects and Machine Learning Platform and Technology teams, contributing to the Create ML framework and macOS app. He speaks often at iOS and Swift industry conferences and teaches online Swift courses with RMIT. James is driven to create change in the mobile apps and machine learning spaces. So please make him feel very welcome for our last talk in this stream for today.
Thank you. Amazing introduction. So this talk is on building thoughtful machine learning experiences and how we can do this in a user-centered way for applications that we will build that use machine learning. So another quick introduction. So that's correct. So I'm currently leading an app studio I've started called Friday Technologies. It is my favorite day of the week, to answer your question as to why Friday. As mentioned, I previously worked at Apple in Core ML, Create ML, and in special projects as well. So really familiar with the ML frameworks across iOS ecosystems and absolutely love them, and still use myself. I started a social networking startup and did the whole sort of startup raising and building an app startup and business and scaling that. And 4 times WWDC scholarship recipient as well. And I also mentor the Apple Foundation's course at RMIT on campus and their Swift courses online as well. If you want to connect, you can find me there. So, what is building thoughtfully? And why don't we start off with why? Why might we build thoughtfully? Well, what happens when we don't build a thoughtful machine learning experience? Lots of things happen. Lots of articles happen, and I'm sure everyone could pick out particular cases of particular machine learning applications that have been built and developed, and perhaps they haven't had the right data, or they've had a bias, or it's caused some prediction on some health data, or something that's perhaps not going to have the best outcome for our users. So it's really important to think about what is this experience going to create for our users, and why are we building it? So we start off with looking at the appeal for machine learning within our project. Is it critical to the experience, or is it complementary? And what value does this bring to our users? Is it something that's going to actually add value, make their life easier, convenience, or is it going to be a hindrance to the experience as well? And delight. So what are some of the ways in which we can improve upon our existing experience and really make this something which is going to be, in some cases invisible, but really creates high value for our users, and in other cases really prominent, depending on the context of our application. So a good quote is, the true measure of successful machine learning applications is not just the accuracy, but also how it enhances our user experience. And this often starts with having a good data set. So with good data, we can build good models. And good models often lead to great experiences. So our data should be diverse, representative, and inclusive to prevent bias. To build great machine learning experiences, you need to think like a user and not just a data scientist. It's always a great idea to start off by thinking about privacy and really thinking about the data that we're using to train our models. So what types of data are we training on? Is this data that we've collected online from a publicly available data set? Is this data that we're taking from our user's device? And if so, is this private user data? Is this data that we're taking from an application that we're uploading and centralizing all this data, and maybe it's personalized information such as health data or sensitive information that our users might not want to share? One of the great ways we can do this and sort of build machine learning models that really takes into account user privacy is by doing it on device. So why on-device machine learning? Well, for starters, it's fast. It runs on the device. There's no need for a network connection, so it also works offline. And typically by nature, it's secure in more sense that our data completely stays on the device. We're not sending it off, and we're able to utilize that data, add to it, and using our on-device machine learning frameworks really enhance that experience as well in ways that we could traditionally only done through having a server-based approach to training a model and deploying it that way as well. So we can do this with CoreML and CreateML. The CreateML framework now works on iOS as well. So previously, if you were using CreateML to train a model, you'd sort of do it in the Mac app or using the Swift framework on Mac. But you can also now run that on iOS and actually create models on the device with no Mac needed anywhere, which is really, really cool. So we've got our model. What do we do now to design thoughtfully? We've got a great machine learning model. Maybe you've created it using CreateML, or used another machine learning framework and imported it in. First thing what we do when we're designing these interfaces is remember to be human. Use human language to communicate about our models. Here's some of the ways that we can do that. So we start off with limitations. Limitations help us to set expectations about the accuracy of our suggestions. So for instance, the Memoji app will alert users if there's low lighting conditions, if their face is too far away, etc. And the example on the slides, you can see the Photos app tells you that you can search for people, photos, and places. And so it kind of gives the user an idea of the limits of the search and what's available, and doesn't make them think that they can type in, the burger I ate last night at McDonald's, or, the sort of more wilder searches. By having that sort of clear limitation in place, our users can actually see that, okay, this is something that I can use, within this context, but it sort of has its limits that are quite clear. Allow corrections. So corrections allow people to succeed even if our results are wrong. So for instance, in the Photos app, if we start cropping a picture or resizing it, it'll automatically crop and resize that picture, but it always allows us to adjust that photo before we go and persist it. Making attributions to be transparent. So our attributions give us insight into where the suggestion come from, which helps the user understand as well, if we do make mistakes in our model, why that might be. And it's always great to relate to the data facts and not just to subjective tastes. Also great to cite your data sources as well if possible. So for instance, you can see here in my Apple Podcasts app, I've got 2 podcasts, and the heading there is, based on my listening. It's not because you like technology. So it's sort of, it's telling me that that's where the data come from, but it's not making a definitive, statement about my interests and sort of about my subjective tastes. And then underneath that, I can see that there's 2 technology podcasts, which are both great podcasts. And using confidence to indicate certainty. So confidence helps us to gauge the quality of our results, which can also impact on how we present them as well. So in the instance of Kayak, they don't say, oh, we're 33% sure this flight's going to go up, etc. They sort of just give you an idea of, our advice is buy or sell. And so they're really relating that back to a really simple phrase, a really simple term that their users understand. And they're really confident with those results. Now, if they're not confident about those results, they don't sort of give some metric or some number. They'll actually say, that they're unsure, or they'll sort of indicate that that isn't something that they advise the user of doing. And using feedback, both implicit and explicit feedback. So this helps our users to tell us about mistakes we might not be aware of. And it's really great ways we can do this. So in some cases, it might make sense for you to have a button, say suggest less like this, or say that was wrong. Or in other cases, you might just show a list of items and, perhaps as the user navigates through that structure, you might re-rank those items in future based on what they tap, given the context. And so using that implicit feedback where the user hasn't exactly said, oh no, this was wrong, but we've sort of learned over time that perhaps that wasn't what they were looking for as well. It can also lead to a really nice, invisible machine learning experience that's super high value for our users. And also taking into mind accessibility. So how do we design machine learning experiences for accessibility? And again, we'll start off with why. Well, according to WHO, 15% of our world population is living with a disability. So how do we actually design a user interface that considers machine learning, but also considers these users as well? So consider alternative inputs. For instance, if you're building an app, go at the classic hot dog, not hot dog. Maybe you've got a live camera view. Perhaps it might be a good idea to also allow the user to upload a pre-existing photo. Perhaps they can take a photo in a camera app or a different application as well. Captions. So if you are delivering any sort of captions, keep in mind to make them clear, concise, and also support voiceover. As well as touch, so allow users to have different options to touch, navigate those interfaces. A lot of machine learning applications, where the model might only say support image classification or sort of one particular domain of ML, it's really great to offer that multimodal experience when you want to consider inputs in that machine learning application as well. And the same with feedback. One of the core differences between machine learning apps and some of the other apps we might build is that dynamic outputs, are sort of more common within machine learning apps. As we update our models, our UI might be showing new elements that we're updated that we haven't necessarily tested with when we developed our app for the first time. this can create certain edge cases that need to be considered when we're developing, and also considerations when we show labels or where we place them, and where things might make sense or not make sense to show to our users. So it's great to have audio feedback and explain results. Again, trying to be clear and consistent, not using sort of super factual bits of information. I mean, if you imagine sort of having an app open and perhaps using voiceover, and you don't want to hear, oh, this is a bottle of sparkling water, and we're 43.79% confident. It's better to just say that we think this is sparkling water. Text feedback, so same goes. So showing our results, making it clear and concise, and aiding that with visual feedback and cues. So, if there's any sort of corrections we can do, or sort of guiding the user through that experience of saying, hey, there's low light, or, maybe perhaps walk back a little bit or move closer, giving them really clear insights as to how they can actually, improve their experience with our product, especially in the case of apps where the machine learning experience is critical to the nature of the application. So let's start off with an example. So I've got a really basic to-do app here. I've written it in SwiftUI. And quite simply, I can sort of go in and I can say I'm going to do a 5-kilometer run. I wish. But I can go and create that. And, it's pretty cool. I can pick an icon that I'd like to put in there. I'm using some SF symbols here. So I've got a popcorn icon. I've got a book. I've got a dumbbell and a briefcase. So these are 4 sort of categories that I've added. And again, this is a really simple to-do app. So, perhaps in the future, I might want to add more categories. And our model might want to predict that. So the idea for this app is that I can go on there, I can type in a task, it'll automatically suggest an icon, and I can click add task, and then basically it'll add that icon with our task up top. So really creating a more convenient user experience, trying to create this sort of invisible machine learning that's not too prominent, but does sort of just help the user go through an existing process a little bit faster. So I'm going to be using the CreatorML app to train my model here. And I've got a data set that I prepared earlier. So what I've done is I've created a folder for training data. And inside I've got 4 folders, one to represent each of the icons that I was using in my UI. Now, of course, in the future, I might want to add more icons, so I could always add more folders, and I could always retrain this model in the future. And within each of these, I've got text files, plain old text files that have different sort of ideas of what I might want to classify as that particular icon, particular SF symbol. So I'm going to go ahead and open the CreatorML app. So I can right-click on Xcode, open Developer Tool, CreatorML, and I'm going to create a new document. Now, quick show of hands, who actually here has used the CreatorML app before? Couple, awesome, all right, amazing. So for those that haven't, basically when we create these new templates, we get a couple of different options here as to what we want to create. There's a great number of tasks that are currently supported, all the way from image classification, object detection, style transfer, hand pose classification, action classification, hand action classification, activity classification, sound classification, text classification, word tagging, tabular classification and regression, as well as recommendation models. So for this exact app, we're going to be using a text classifier. And based on the input that the user types in for their task, we're going to generate one of those suggested icons. So I'll go ahead and select text classification and select next. And I'm going to give it a name. I'm going to call it the Dev World icons. Nice and original. Great. So now I'm in my first window. I got my model sources on the left. So these are different iterations and different versions of the model that I train. So I can kind of experiment with more training data, try different validation data sets, and also change the algorithm that we're going to be using to train our models. So I'm going to click on the plus button here, and I'm going to open up the training folder and simply open that up into CreatorML. I can see that I've got 4 classes, so 4 potential icons that we're going to be training for, and also 51 items in total that we'll be training. So I'll click the train button, and CreatorML does it very quickly in this case. But we want to train a couple more models as well. So I'm going to duplicate this model, right-click and duplicate. And I'll try a bunch of different models here as well. We'll do some transfer learning as well. And we'll let that train. And I can see the training progress in real time, which is awesome. Now that that's done, great. I can also look at my data sources as well, again, to sort of look at those labels that I have and sort of how complete my data set is. I can see that it's relatively well balanced. Obviously, it's sort of quite a small data set, and there's times where sort of CreatorML will give you tips here as well, so ways that you might be able to improve your data set too. If I go onto my models, I can see there the different training and validation accuracies. So in this case, it looks like our first and third model trained pretty similarly. And I can also look at evaluation data as well to see exactly, drill into those details and see how it did, and particularly how good it was at looking at that training and validation data. In preview, I can go ahead and try out a few phrases. So before I go and put this into my app, I want to make sure that it works. I don't want to be putting a model into an app where someone types in they're going to be doing a run and it's time that they're going to be reading a book. So I'll go and create one for a run, so 5-kilometer run. And I can see that the highest confidence prediction is a dumbbell. I might also do send a report to Zach. Awesome. I can see that it's got the book. And perhaps we'll do watch the new keynote. Awesome. And popcorn. Now I can try different models, so I can click here on the side and I can see watch the new keynote come through as a book. And in this first model, it'll come through as popcorn, probably the most accurate. Sending the report was the briefcase and the 5-kilometer run was the dumbbell. So again, even though this model had different amounts of accuracy with respect to the validation and the training, I can actually drill in, try my model out and say, okay, I think this one actually works quite well given the use case that I want to try. If I look at my output, I can see my model here as well, and I can simply open it in Xcode, or I can get it on my desktop as well if needed, or share it off to a team member. If I was working in an app where I was collaborating, maybe I was a data engineer building the model, and somebody else was designing the app. So I'm going to take this back to Xcode, and I'm going to drag in from CreateML, just drag in my model from the icon, and make sure that that's copied over. If I click on this in Xcode, I can see the ML model file in Xcode. And again, I can see information about the author, the description that we filled in from CreateML, and some information about the version of CreateML that was used to train the application as well. I can use our preview again. Great, so I can see that that's classified correctly. And I can open up predictions. This will show me both the inputs and the outputs of the model. So different types of models will be able to use different inputs and different outputs, whether it's an image or a text. It gives us a little bit more information about how exactly we can use this model. And I can also check the performance of the model as well. So I was building something that was going to be used quite extensively. I can go ahead and create a performance report. And I've only got my MacBook connected at the moment. So I'll go ahead and do this on all the CPU, neural engine, and GPU, and just click Run Test. So it'll take a second to let that run. And straight away, I can start seeing some results, which is pretty cool. And once that completes, I can also open it up in Instruments. So if I wanted to see and really drill down into more detail about how the model's running, I have all the information there as well that I can jump into and see all those metrics around predictions and actually loading in the different various frameworks that are required to run my model. And last but not least, utilities, which allow me to set up things like model updates, encryption, and cloud deployment. So this is really good in, say, in this context where I've got my app, in the future I might want to train more icons, or I might realize that perhaps the data is not that great, and maybe I want to go ahead and create some more interesting data. I can always update that online as well. Awesome. So I'm going to rename this quickly to icon classifier. And you'll see there that this updates what's called the model class, which automatically generated a Swift model class for us. If I go into my content view and I run this, we've got our really simple app, which will pop up in a second. Cool. And I'm going to go ahead and create a version of my model. So our model is icon classifier. And we create this with the configuration. I'm going to be a bit cheeky and force this because this can throw. And what I want to do now is that when our users start typing in, I want to give them instant suggestions. So as they're typing, show up that icon, and of course allow them to always change that and create a correction at the end. So I'm going to do on change of our new task title. I will run our checkout prediction, our model, prediction from our new value. Then we will simply set the new task icon to the predictions label. So our prediction here, you would have seen on the previous page when I opened up the model that it had those outputs. In this case, our model only outputs a label, but certain models might output more bits of information. So I'm particularly caring about our label here. And now if I start typing, I do 5-kilometer run, you can see that it automatically changed over to our dumbbell. I could change this. I could say, watch Netflix, and straight away it's come up and it's given me that popcorn icon as well. So really simply, we've created a sort of invisible machine learning experience, and it really added only a few lines of code to our project, which is really good. Alrighty. So how do we improve from here? Well, there's a number of things we can do to improve. This is obviously quite a simple to-do list example. But we can start off with obviously quite clearly some UI improvements. Obviously the UI was not super polished for the talk, but it's just the purpose of showing the ML experience. But we could add some attributions. We could say that, this is based on your past selections. So perhaps if we were using that data from their past selections, we could showcase that perhaps that's where our data is coming from for suggesting the icon. So quite simply adding text to the user interface really adds a lot of value to our users, so they're not sort of going, hang on a second, this icon's just changed last minute and I'm sort of confused as to why. We can project confidence. So in this case, if we're not confident about what the user entered, we can silence the results. We don't show anything, or perhaps we show a question mark. Or even better, we can say that we're highly confident this is what you want. Perhaps in the future, maybe that we have a list of icons so large that we end up having something where it's more of a grid, and maybe we section that off into two sections, one which is suggested icons and sort of all icons. So depending on your app, depending on the context your app will be used in, really think about the user and how they're going to want to see those results, be that filtered or sort of unfiltered results as well. And what about wrong predictions? They're going to happen, right? We're not perfect. We can't build the perfect model that's going to support every single to-do list. I'm sure everyone's to-do list is going to look slightly different from one another's. So we allow the user to make corrections. So in this case, if users typed in, that they're doing a dev sprint, which is pretty different to a sprint that you might make out if you're going for a run around Albert Park or perhaps down the Yarra River, we allow the user to make a change. So they go on their picker and they say, actually, this was not the dumbbell, this was maybe more the briefcase. And so by doing this, we're creating that implicit feedback. The user's gone and made a change, gone and made a correction. And we can also train a new model on the device as well. So instead of using the CreateML app or using the framework on our Mac, we can actually integrate it into our application as well. So one of the advantages of this, again, is that CreateML is on device, so that data will never leave the device, but we can simply take that feedback, feed it through with our original training data, and create a new model for the user. We could also update that model as well, and upload all that data somewhere central, and then obviously we train it up. But of course, the last thing I sort of want on my MacBook is all my users' to-do list information, and that might be private. So it's a really good idea to sort of do that on device and sort of train up these models in a way where that data never leaves our device. So what does that look like? So we accept some feedback, and we store it on our device or submit again to our central database. We start training a new model. This happens on a background thread. So we can do this in the background, fire it off. You probably don't want to train one every single time they make a change, but periodically, if we go, okay, if they've made enough changes, or perhaps we allow the users to select their own icons and add their own icons, we start getting more data that we can use to create these predictions with. And once our new model is outputted, we've got to make sure we store it somewhere. Perhaps we can store it on CloudKit or on iCloud. So if you're building an app that's cross-platform, that model can straight away be used on Mac, on Watch, and sort of on iOS as well. So if you've got a Mac application, you can perhaps train on that and sort of share that model across as well. So, quick recap. We're building machine learning experiences. It's always great to design with the user in mind. Great data will produce great results. And consider how we show our results, considering things like limitations, attributions, corrections, and our feedback mechanisms. And consider how we project confidence within our results as well. These are some of the core components we can use to create thoughtful machine learning applications for our users. Thank you.
Thanks, James. That was fascinating. It's surprisingly simple to put together quite a clever little app. Do we have any questions? Excellent.
Is the ML app deterministic with the dataset?
So you can sort of give it a bunch of different types of data that you'd like to give it, and I think one of the key things here is that obviously if you are training a model like I was sort of in CreateML, I'm going to need to have all that data there. I'm going to have to have all my labels, everything's pre-labeled, pre-sorted. That's not always going to be the case when we train obviously on device. We might not have the ability to embed our entire data set on the device as well. And it might be sort of dynamic in the sense that we're going to be adding in the user feedback, and my feedback might be different to your feedback. So the way we sort of create that data table on the device before we train it, send it into the model is going to be different, which is going to produce different results as well. So it's usually a good idea to sort of at least report, if you're not going to be sending up the data to somewhere central, but at least report those metrics as well. So, I can say, okay, my user's getting personalized models, but if they're correcting them half the time and it's not getting better over time, then I have some idea to say, okay, well, perhaps this sort of approach of personalized models isn't working, or perhaps I need to train, or add a better, direction to the user as to how they can actually go and, create better data themselves as they go and select those icons as well.
Firstly, a great talk. Thanks, James. So forgive my probably naive question, but so you mentioned you start with a model, like you put that in your app, and then you can update that based on the user's use and sort of suggestions and stuff. How does it work when you then say ship an update to your app with a new and improved model? How does that take into account what the user has also fed it?
Great question. So in this particular approach that I had on the slide where I was creating sort of a new create-ML model, the notion that I had, at least for that sample demo bit that I'd built, was kind of, it would save the model to the device. And so in theory, then if I was to update a new base model, it would sort of replace the model the user had on device, which would probably work in this case, right, where we have a few different icons. But then if we had the ability for you to have custom icons, we'd obviously lose all of that customization. Depending on the way you structured your model, you could potentially change just certain parts of that model, and you might have a sort of personalization component towards the end of that, like a different layer sort of towards the end, which will allow you to keep those users, personalization state as well. Typically, I think, in a small app like this, it's kind of all right to just, ship a base model and sort of go, okay, we're going to, keep those personalizations and not really ship an update to it. But then if we were to ship an update, you'd have to really think about, okay, is my base model now so much further along than what I had in the previous version that it's worth replacing the user model. Perhaps that's something to A/B test, or you start getting into, drilling into making a model that's custom, or perhaps even running both models and, sort of getting a fusion of the results if you'd like, as an option. There's a few different ways you could sort of tackle that, each with their own sort of storage implications and kind of, speed implications as well, depending on the type of model you're running.
So also great talk, and I'm also impressed by the simplicity from a developer point of view. If you have a very large model, would it make sense to download that model dynamically? Is it necessary to embed the model in Xcode and in the binary, or can we have the model live somewhere in the cloud and download it when there is an update, or download it at first run?
Great question. So I think it really depends as well on like how critical that is to the experience, right? So in my case, it's a to-do app, and let's say I'd gone and I added 300 icons to this app, and for some reason my model was like 100 meg. I don't think anyone's going to want to download a to-do app that's like 150 meg just to add some to-dos, right? And so maybe if the app was 5 meg, but I download it dynamically, I could just have the picker be a default picker. I'd have no sort of smarts around it. And in those cases, dynamic works really well because you can actually have, you can download it. You've also got a mechanism then to sort of have an update. Commonly, people will sort of use like a ML model deployment with CloudKit and sort of have it in their public CloudKit zone, and that way they can just sort of easily update that model too. And it's great because you can download it on device and have it ready to sort of run at that time. Of course, certain apps, let's say, going back to that sort of hot dog, not hot dog example, it wouldn't make sense to download the app and then have to wait for a model to download to classify. So I think if it's sort of core to the experience of the app, then it's a question of, okay, can we have this model? There are some techniques you can do to reduce the size of the model as well. So we could have a reduced size model that's perhaps bundled with the binary and then sort of download a better one later on. You might also localize your models too, right? Like for instance, you might have multilingual models that we download or things like that. So sometimes it's good to have like the base language, or, popular languages downloaded and then sort of download those variations later on too. So I think it's really a question about where does the model fit in the user experience and how do we want that to feel for a user. Like first coming to the app, do they have to wait, or is it something that they can wait while they're getting the whole app loaded through the App Store?
A question about, I noticed that you have different models depending on what is the aim of the model, the problem that it needs to resolve. So let's say at some point you created a model using one type of model for classification, but then you realize that it doesn't fit the problem too well, and you want to change the model type to something else. What happens with the data that learned from the user and all that?
Totally, great question. So in this case, I've got a model and say I've trained it up using CRF, or I've sort of changed those options in CreateML. So long as those inputs and outputs are the same, it's going to sort of work relatively okay. Of course, that becomes a question then if we train a much better model in-house, we might say, well, okay, let's let's nuke the user's model and sort of use our new models, our state-of-the-art model if you'd like, and deploy that live. Of course, we can always keep that feedback as well on device, whether it be core data or sort of persisting that locally to then update models in the future. And maybe we just update again, like if we sort of break our model down, we can sort of update particular layers of it and say, okay, well, we're going to keep this part of our model and sort of update that, but then we're going to repersonalize that last little bit towards the end. So it is a bit of trial and error getting that right. And again, it's really important to sort of look at those accuracies as well for what that user model is, especially based on their feedback. If we're collecting feedback, it's really great to collect, well, we did it right 9 out of 10 times and we're happy with that, or actually every time the user types in, they're changing the icon here, and that's an issue. So maybe we have to nuke that model and go back to the default one. So sort of comparing those as well on the device.
Any more questions?
Thanks for the talk. In the demo there, you had the CreateML interface, and it had a whole bunch of sort of off-the-shelf classifiers, image and the ones that you use and all that sort of stuff. And in the dub talks I've seen, I get the impression that the Vision Kit team, that they have access to a whole bunch of other much lower level tools. Is there like an intermediate step where we can say, okay, none of the CreateML classifiers do what we want, let's roll up our sleeves and try and jump in? Or is it just we have to move to a totally different ML system at that point?
Great question. So there are some models that ship with the system that, certain things like text recognition or whatever that are just available through the APIs, or things like word tagging, if you want to get like different parts of speech out. So, and those you don't need to train a model. There's actually system shipped models and APIs that sort of come out of the box. In the case of those, CreateML models that you've trained, or even for models that you sort of produced with, say TensorFlow or PyTorch and converted over using CoreML tools, you can, I suppose, update those models. But what happens with that as well is, say you've got like an image classifier in CreateML, you can use, you can pass in perhaps a buffer or a CG image, for instance. And so how you want to do that, how you want to get there, whether you're taking, samples of images, whether you're, creating a custom model that takes, temporal information and some other sorts of information you're going to pass into that model, it's really up to you as a developer. Like, you don't have to say use the recommended way and pass in an image from an image picker. You could, perhaps do that on a live stream, or you could really just use the model and say, hey, here's an image, give me an output. But that image might be, maybe it's a screenshot or it's a UI element, or really depending on what you've trained on. You don't have to necessarily use, the image classification in the typically demoed sense, if you'd like, of say recognizing a plant or something like that, because you've got the option to put whatever images you'd like through and really change those inputs and outputs.
I have a question. Of all the times that you've had a client or a project stakeholder say, we would like to use ML to solve this problem, what proportion of the time was ML actually what they wanted or needed?
Very few, very few. And it's quite a common thing, I think, right? Like, a lot of people will sort of see the buzzword and hear the buzzword, and, especially lately, I mean, a lot of people are like, we're going to add GPT into this, chat GPT into this. And it's like, great, sounds good. Why? And oftentimes the answer is not one that I would say is pretty satisfactory, but it's kind of, oh, well, we need to, right? And it's like, well, no, not necessarily, right? Like, I could add GPT into this to-do app, but it wouldn't make sense. It wouldn't make sense at all to sort of go down that path. I mean, maybe you could have some really cool features that summarize your day or something, I don't know. But it's kind of like really thinking again about that user experience and, is it the right approach, or would a simple summary do? Like,
well, you definitely get funded.
Definitely, yeah.
All right, let's give a big hand to James. Thank you for that.
Thank you.